Good morning, ladies and gentlemen. This is section 5.5 of Mrs. Quinn's Geometry, and today we're going to continue our work with proofs, and we're going to focus on proofs using reflections. I'd like you to go ahead and write down this perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. I'd also like you to recall from the figure reflection theorem that if a figure is determined by certain points, which are reflected over a line, then the corresponding figure is determined by the reflection images of those points. So let's go ahead and work with that perpendicular bisector theorem. If WY is perpendicularly bisected by this line XZ, any point on this line is equidistant from its endpoints. And so we're going to look at that for a second. If, let's say, we know YZ, I'm told is 8, and I am also told that XW is 14. What that perpendicular bisector theorem tells me is that this segment must be equidistant from this endpoint, must be the same as this segment. So this segment must also be 8, and this segment must also be 14. So when it asks me for XY and WZ, XY here has to also be 14 like this segment, and WZ has to be 8. That's from the perpendicular bisector theorem. Now let's look at proofs. Suppose I am given that the reflection over M of X is Y, and I need to prove that AX equals AY. Now the only thing I haven't mentioned yet in my proof is this point A. So I'm going to go ahead and mention that the reflection over M of A is in fact A, and that's due to the definition of reflection. And then why do I know that AX has to equal AY? Did you think about it for a second? What theorem did we just learn that we know gives us that solution? Or not a theorem, I'm sorry, definition. I would say AX equals AY because reflections preserve what? Well, they preserve distance. So I would simply state reflections preserve distance. And now you can see why I actually tested you on chapter 4 on what reflections preserve, because we're going to need to utilize those in our proofs. All right, let's try one more together. If I am given these reflection pieces and I need to prove that triangle ABC is congruent to YXZ, I want you to think about how we're going to do that. I'm going to start by writing my givens while you're thinking. All right, first of all, I've reflected each point in this figure to a point over here. What theorem does that remind you of? That's the figure reflection theorem that I reminded you of on that first page. Now I can say that this shape is the reflection of this shape. Would you agree with that? So I can simply say now, if I reflected point by point, that hey, the reflection over M of ABC equals YXZ. And that is due to the figure reflection theorem. And if you don't remember it, just go back to that first slide. And now I've shown that these shapes are reflections of each other. How do I know that they're congruent? Do you remember the definition for congruence? The definition for congruence said that Well, it's just the definition of congruence. I don't have enough time in the video to remind you of the definition of congruence. But I want you to go ahead and go back and reread definition of congruence. I think you'll agree with me when you read it. So once I show that they're reflections of each other, they are definitely congruent. I'll go ahead and talk about congruence. Remember, we defined congruence to be something that an isometry had happened and then its new shape was congruent to its original shape. The definition says it way better than that, but go back and reread that. For tomorrow, I have something very different from your video question. I'd like to introduce your first idea from section 5.6. We're going to be talking about things that are uniquely determined in 5.6. And for tomorrow, I want you to double check your theorem definition postulate page. I want to make sure that it has all the theorems, definition, postulates that I've listed on the next slide. And if you haven't made one yet, tonight you're going to go ahead and make one because you're definitely going to need them for writing proofs. So today is the day to get it done. Tomorrow I'm going to collect everyone's theorem, definition, and postulate pages at the beginning of class, like a video question, so I can double check them and then I'll give them back to you because you are definitely going to need to utilize them. So let's go ahead and go to this next slide, and please make sure that you have all of these. And the theorems that we did today, some of these I just labeled as theorems. Make sure that you have all of those dealing with perpendiculars. Like today we did the perpendicular bisector theorem. So I will collect those at the beginning of class tomorrow, and I will see you then.